Hello and welcome to another chemistry topic for today. If you are watching these notes when they originally assigned, go ahead and start setting up your focus notes. It's day 3 of Unit 10 on solutions. Fill in the date. The topic for today is dilutions. So the essential question that we will be answering during today's lecture is, how do I make a dilute solution and calculate that new molarity? So we'll be talking about dilution. What does that mean? We'll use molarity. There's a new calculation that I'll give you. So that's the focus for today. So go ahead and finish setting up your notes. Pause the video if you need more time. Otherwise, let's get into it. So the first thing is just, okay, if we're going to make a dilution, so if that's a term we use, what does that mean? So first of all, a dilute solution means that you have relatively a small amount of solute. So that's what dilute would mean. So not very much solute in your solution. Compared to a concentrated solution would mean that you have a large amount of solute in your solution. So visually here, you have a lot of solute particles. So that's what this is trying to show. So the blue dots are your solute particles. In that amount of solution, not a lot of solution. So this would be concentrated. There's a lot of solute in that given amount of solution. So if you dilute it, generally what that means is, so generally you can dilute a solution by adding more solvent. Well, that's what this visual is showing you. So you didn't do anything to the solute that was already there. You just poured in a bunch more solvent. So then you can see now you've got more solvent particles, the same amount of solute that you had before. So now this is more dilute because compared to the amount of solution, you have a small amount of solute. And you did that by adding more solvent. Therefore, the moles of solute that you started with are equal to the moles of solute that you ended up with. So we didn't change the solute, we just added more solvent. The liters before is less than the liters after. So because we added more solvent, we increased our solution size, and that changes what is known as the concentration or the molarity, right? So the amount of moles of solute stayed the same before and after, but we have way more solution size or higher amount of liters afterwards. So the liters afterward is greater than the liters before. So the liters before is less than the liters after. Okay, and because all we did was add more solvent. So that decreases the concentration, decreases the total molarity because you have same moles, a lot more solvent or solution. Okay, that's the idea behind making a solution. So if here's a useful trick we can use. We know that molarity, which measures concentration, is moles of solute over liters of solution. Okay, if we rearrange that to just focus on moles, we could say that the moles of solute is equal to the molarity times the liters of the solution, because that's the thing we're focusing on. How did the molarity change when I changed the liters of solution? Well, like we just said earlier, the moles of solute stays the same. So the moles of solute before equals the moles of solute after. All right, let's do some other substitutions. So the molarity and the liters before would equal the molarity and the liters after, because we did some substitution, because the moles of solute before is equal to the moles of solute after. So the molarity before times the liters before equals the moles after times the liters after. How did we do that? Did you follow what I just did? Because the moles of solute before is equal to molarity times liters. So that's what we have, molarity times liters. The moles of solute after is equal to the molarity times the liters, because those are equal to each other. So molarity after times the liters after. So we did this is known as the transitive property, if you remember in math. So because these two things are equal to moles, and these two things are equal to each other, this is equal to the other version, the moles after. So that's the little substitution that we made. Since the moles are equal to each other, the molarity in liters before is equal to the molarity in liters after. But that's a lot of extra stuff to write. So the way we represent this is the molarity that you started with times the volume that you started with equals the molarity that you end with times the volume that you end with, or the liters that you end with. This is known as the dilution equation. Okay, well, how does this work out? Because if your molarity that you started with, you had a small amount, and then you added a lot more solution, so then the volume went way up, then the molarity would go way down. So dilution. Oh, okay, that makes sense. Because you added more solvent to dilute it, so the volume goes up and the molarity would go down because moles has to stay the same, right? To keep this equation equal. So that's kind of the idea that we're going for. So look at your original molarity and your original volume. If you add a bunch more solvent to dilute it, that means that you can figure out what the new molarity is because you know how much volume you added, or any other way. Like if you know you know what your new molarity and your new volume is, you can figure out what the original molarity happened to be. So there's different ways you can solve for this. But basically, you'll be given 3 of these 4 things, solve for what's missing to answer whatever the question happens to be. Okay, so what kind of a question could I ask you? So that's a lot of like general talking. Let's do an example. Let's say I had 25 milliliters of a 1.0 molarity copper sulfate solution. So there's my 1 molarity copper sulfate. You can see it's kind of a dark solution because 1.0 molarity means there's 1 mole per liter of solution. Here's 25 milliliters of that solution. So I want to dilute it to 750 milliliters and figure out the new molarity. Okay, so when I dilute it, that means I add a bunch of water. And so what I'm going to do is I'm going to start with 25 milliliters and I'm going to put that in a beaker, all of it, 25 milliliters of a 1.0 molarity solution. I'm going to add a whole bunch of water until the final volume is 750 milliliters. Okay, well, that makes sense. It's a lighter color. Sorry, that's what I meant to say first. It's a lighter color, which makes sense because I started with this dark color that was 1.0 molarity, and I added a whole bunch of water. So I have the same amount of moles in here that I have in here, but there's a lot more solvent. So moles of solute is the same, but there's a lot more solvent. So think about those moles being spread out in a bigger space, volume, so it's not as dark of a color. But I want to know what that new molarity is. I can predict that it's less. Why do I know it's less? Because I kept the moles the same and I added a bunch more solvent. So there's a whole bunch more solvent. It's diluted now. Well, what is the actual new molarity? Well, here's that new equation. M1V1 equals M2V2. My volume was the 25 milliliters I started with. My molarity was that 1.0 molarity that I started with. My ending volume was the 750 milliliters. I can see that in this example. What I want to know is my new molarity. I can predict that it's lower, but I want to know how much lower. So I take my 1 molarity as my M1, my 25 as my V1, M2 is what I'm solving for, so then 750 is my V2. I'm going to solve for M2, just do some algebra. So then really I'm dividing both sides by 750. It cancels over here, so just doing some algebra here. M2 equals 1 molarity times 25 milliliters divided by 750 milliliters. Milliliters cancels. I'm left with molarity, which is what I'm looking for because I'm looking for M2, and I end up with 0.033 molarity. So that is the concentration of this new solution that I made because I added a whole bunch of water. So I went from 1 to 0.033. And that makes sense because look at it's a huge volume, 750 compared to the 25 that I started with. And so this might be useful if I bought what's called a stock solution of a chemical. I can dilute it down to any other molarity that I need to and figure out, well, how much water would I need to add? That's a super common thing I do for labs all the time. We buy from a chemical company stock solutions that are high concentrations, sometimes even like 18 molarity. And so I can say, okay, I want for my lab to have a 2 molarity solution and I need 4 liters of it for all of my classes. I know that the stock solution is 18 molarity. How much of that stock solution do I measure out? And then I would measure that, and then I would add enough water to make that 4-liter solution like I was predicting, like just making up an example. So that's another practical application of this dilution equation. All right, that's it. That's our new topic for today. So go back and write a level 1 question, a level 2 question, and a level 3 question from today's notes, and then also do a summary that reviews today's notes and goes back and answers the EQ. Take that time to process and think about these notes so it wasn't just you watching, but actually get your brain engaged and make sure it makes sense. Just a reminder, if you're watching these notes for Try3 class, that solutions practice from last week should be, or earlier this week, should be done. It's technically due today. So if you're watching this video on the day it was assigned, so the video was assigned on May 7th, that solutions practice should be turned in today. There are some unit practice problems related to today's notes, just a couple, but it's a nice way to check it, see if this new notes made sense. And then just remember that you can use office hours to get help. So it's not a in-person class day today. So you can always use office hours to get help as needed. All right. Thanks so much for learning more about dilutions with me. We'll see you next time.